let's get started here. Introducing AWS DeepRacer. So we introduced DeepRacer to, at the time where machine learning was kind of, on the rise.
Sorry to interrupt. Is your slideshow, which slide are you supposed to be on? Because currently we can just see machine learning on AWS, so I'm not sure if that's intended.
Oh no, are you... I was on slide 7. Do you see my screen now?
Yeah, just wanted to check.
Okay, no worries. Let me know if there's a lag and if I'm going too fast, but did everyone get everything? So we kind of went through the overview of AI ML services at AWS and Amazon, and then we talked about the higher level services with the AI services, but in addition to that, we have AI devices. Am I caught up right now for everyone? Yeah, is everyone caught up? Can you see introducing AWS DeepRacer?
Yes.
Yep.
All right. So yeah, in 2019, we released AWS DeepRacer Generation 1, where it's a single camera and single camera with just time trial capabilities. In late 2019 and early 2020, we released the AWS DeepRacer EVO. With the EVO, we enhanced, kind of the reinforcement capabilities of the AI device. We have stereo cameras for depth perception, a LiDAR sensor on top of the car, for object detection, object avoidance, and head-to-head racing. Now, for developers and practitioners and enthusiasts, you don't necessarily have to have a DeepRacer car to get started. So within the AWS console, you do have a 3D racing simulator. This is where you will train your model and kind of evaluate and see results in real time. In a fun way of getting, customers across the globe, we have AWS DeepRacer League and community races. Community races are private races where, whether you're a big company or cross company or with partners, you can create a community race and, have fun and kind of in a spirit of a competition to, see how your models perform in the track. I really want to focus here. So I'm on the slide that says reinforcement learning for the Sunday driver. Does everyone see that?
No. Currently, we just see introducing AWS DeepRacer.
Okay. I'm in an office, so my connection is pretty good. So I'm wondering if it could be the meeting that's the Google meeting that's lagging.
Maybe. Can you try are you just sharing an application window?
I'm sharing a presentation.
You might want to try sharing your full screen if that presentation is full screen.
Okay. Do you see this?
Yeah. Could you try switching to another slide?
Yeah.
Yeah, that works.
Okay, awesome. Cool. So reinforcement learning for the Sunday driver. So again, to get started with reinforcement learning and using our AI devices, you do not have to be a machine learning practitioner. And in fact, we kind of want, brand new users who haven't really experienced or had experience with machine learning or reinforcement learning. And it's a fun way of getting your hands on experience with the concepts and to realize results very quickly in order to, understand how to get started. Now, definitely machine reinforcement learning projects doesn't necessarily have to span, autonomous driving, but it's a fun way to get, understand the concepts of an agent, an environment, and all the rest with reinforcement learning. And that's what we're going to get into in the next couple minutes. Reinforcement learning in the broad AI context. Okay, so for the folks here, I know there's a couple sessions today with deep learning and some AI and ML, so I don't want to belabor it, but this is just to provide context of where we're going in terms of reinforcement learning and DeepRacer. So as you know, artificial intelligence is a broad concept where we are trying to seek to create machines that seem to have human intelligence. Now, this is a broad and general concept. One aspect that humans are good at is learning how to classify things or events, and also make simple predictions based on past behavior. if we look here in machine learning is a subset of artificial intelligence that aims to replicate this human ability. Machine learning uses statistical techniques to build models that are good at making predictions. Now, these statistical techniques learn from data to figure out what the patterns are and ultimately what leads to prediction. So yeah, looking closely with machine learning disciplines, we have three different areas of machine learning. Traditional, I think folks here are, whether aware or have touched supervised learning. It's an example-driven training. We have labeled data of known outputs for given inputs. A model is trained to predict an output for the new inputs. So I'd like to say, for supervised learning, rule of thumb, for me, I think linear regression. That's a supervised learning technique in machine learning. If we think about unsupervised learning, inference-based training with unlabeled data without known outputs. A model is trained to identify related structures or similar patterns within the input data. So for unsupervised learning, there's no known output. So, for me, I'm thinking k-means clustering or even just clustering in general for unsupervised learning. And then next, reinforcement learning. It's a type of machine learning in which an agent explores an environment to learn how to perform desired tasks by taking actions with good outcomes and avoiding actions with bad outcomes. Reinforcement learning model will learn from experience, and over time will be able to identify which actions lead to the best rewards. Now, I think we've all, had some experience with reinforcement learning in our lives. Think of, when we want to train our dogs to perform a new skill, we say roll over or sit, we use treats as a reward to train a dog to roll over. Now, this reward is to incentivize. Now, what happens when they don't do that? Let's, in this picture right here, they get into some trouble when I'm off in the store and I come back and like, oh man, what's going on? We definitely don't reward for this type of behavior. So we don't want to give treats. We want to say, you perform this action, but it doesn't warrant a treat. Training can be simple, right? So it could be simple things like simple actions like sit or stay, or more complicated series of behaviors. Now, again, if we're successful, we can get our dog to train to do pretty much anything. So hopefully we have the context of reinforcement learning concepts. Now let's get into reinforcement learning terms. We have an agent. In this case, for deep learning, the agent is the car itself, represented by the car here, virtual or physical. More specifically, the agent embodies the neural network that controls the vehicle, taking inputs and deciding actions. Next, where the agent will have to negotiate an environment. So the environment in our case here with deep learning is a track, whether it's a complicated track or a simple track. This track defines what the agent interacts with. The agent explores the environment to collect data to train the underlying neural network. Now, how do we get around the track? So I mentioned either the stereo cameras or a single camera. So a state. So the agent has to know what state it's in its environment. So a state represents a snapshot of the environment the agent is in at a point in time. For AWS DeepRacer, a state is an image captured by the front-facing camera of the vehicle. Now, once the agent knows what state it's in the environment, it will now have to decide on which actions to take. So if you think about actions in our case, it's a move made by the agent, in our case, the car. An action corresponds to a move at a particular speed or steering angle, kind of making its way around the track and negotiating turns and objects where required. Next, we have the reward. So again, the reward is a score given as a feedback to the agent when it takes an action in a given state. In training a DeepRacer model, the reward is returned by a reward function. In general, you define or supply a reward function to specify what is desirable or undesirable action for the agent to take in a given state. And next, an episode. So what is an episode? An episode is, in our case, an iteration of a series of states, but in our case, you can think of an episode is where the agent starts from the position and a termination state. So just think starting line and the finishing line. So episode in our case in DeepRacer is just completing a lap. But most importantly for reinforcement learning, the reward function incentivizes particular behaviors, is at the core of DeepRacer and reinforcement learning in general. Sorry. Okay, here we're training a vehicle to drive itself, right? So it can be tricky to visualize the process of training. So I wanted to, this slide is really helpful so we can take a look at a simplified example. And in this example, we want the vehicle to go from the starting point to the finish line following the shortest path. We've simplified the environment to a grid of squares. Each square represents an individual state. And we allow the vehicle to move up or down while facing in the direction of the goal. Now, when you break the track into individual squares in a grid, we can assign a score to each of the square in our grid to decide what behaviors to incentivize. Here, as you can see, we designate the squares at the edge of the track as stop states. So you see the X there. If the agent hits that, they're off track, they don't get a reward. And since we have to incentivize the vehicle to learn to drive down the center of the track, we provide a higher reward for the squares in the center line and a lower reward elsewhere. But if you see, we're incentivizing the car to gain the most points following the straight line. But let's say they veer off. The agent will know it's still getting some rewards, but not maximum rewards. And that will help with its training and the way it learns the environment, because to the agent itself, it doesn't even know what environment. So it has to know, based on the reward function, where it's incentivized to receive the most cumulative rewards. Iteration convergence. So if you can see here, it's on the left panel, you can see the training graph. As it's kind of feeling its way, it's in this exploratory phase where, hey, we are going left or right or left, and it's finding where the maximum reward is. And ultimately, when your trained model reaches convergence, it is exploiting its environment to maximize total reward. So, that was the simple grid example, but let's look into what you will see as you train your model in the AWS DeepRacer console. So look on the left here, you'll see, as you're training the first, hour, half hour, your car's gonna go off, the road or track is gonna hit the wall, but that's okay, because in reinforcement learning, we want the agent to see what it can do. It's gonna experiment, it's gonna say, hey, what happens if I take a left? What happens if I go straight? Oh man, I just went off track. It's not getting its total rewards. So again, when you see this in your first phases of training, it's pretty good to see this because it's trying different things out. But ultimately, depending on how the reward function is programmed, we want to get to a level of convergence where the agent is in full exploitation mode, where it is exploiting what it's learned on the track to receive the maximum reward. So, by, hour number 2 or 3 of your training your DeepRacer model, you should see something like this where you're incentivizing the agent to follow and stick to the center line. Also, you can also program in to, give rewards, even if it stays within the white boundaries. So, a number of different things you can think about in terms of assigning rewards to the agent for it to exploit the track itself. So let's review. We talked about reinforcement learning. We gave an example of, many of us have real world examples of what reinforcement learning is. The key to reinforcement learning is the reward function. How do we incentivize the agent to maximize rewards and maximize cumulative rewards? And then next, we showed a very simple example of what that really means in terms of incentivizing the agent to perform a desirable action to complete its goal. So how does learning happen? Okay, so this is kind of a little more, a little deeper. So just bear with me here. We mentioned the agent in the car and iterates with a simulated track environment during training. What we do with the state kind of controlling the state of the agent, it interacts with the simulated track environment, and ultimately what we want to generate is a fully trained model. Training, again, is an iterative process. In a simulator, the agent explores the environment and builds up experience. The parameters passed in the reward function describe various aspects of the state of the vehicle, such as position, orientation of the track, its observed speed, steering angle, and much, much more. Now, this is where the reward function comes in. The experience collected are used to update the neural network periodically, and updated models are used to create more experiences. So when we create that rich experience trained into the model, we can then, decide we're ready to at least try this, in an evaluation mode. Or if you feel it's right there, maybe 75%, you could take that and clone and iterate further to fully optimize, the agent to fully exploit its environment, in our case, a track. So with the DeepRacer service itself, we use a form of policy optimization called proximal policy optimization. Again, this is a method where we parameterize our policy function. The parameters are simple weights in a neural network, and the neural network represents our policy function. All this policy function does is take an image, known as the state, as input, and outputs an action, which is a right, a left turn, speed up, speed down, or steering angle. And thus, it's going to map the state to an action. We then optimize the policy to get the best action from each state. And the goal is to get the maximum cumulative reward. As we mentioned earlier, we train our model as we update the weights by trying to maximize the cumulative future reward. And in doing so, we give higher probability to the action that leads to the higher cumulative future reward. Now let's look at the neural network that represents our policy function. Now I mentioned the default architecture is a 6-layer neural network. And we're going to stick in this example with our 6-layer neural network. In the first layer, it's our input layer, the camera and the deep lens, whether it's stereo cameras or single camera. It's then followed by a 3-layer convolutional neural network. Identifies the features from images needed to make driving decisions. And finally, we have 2 fully connected layers to help determine what action or driving decisions we should make an output into. Each node determines how much weight should be given to a certain feature in the image. Now, during the training, the weights are constantly adjusted. Adjusting the weights means adjusting which actions the car will take. Weights are adjusted such that the car maximizes expected cumulative reward during race training. So, I feel like, many times it's hard because I don't have an example or real card to show you. So hopefully this gives you just a foundational, insight to reinforcement learning and some of the services that AWS offers in respects to AI devices for, developers and software engineers to get really started on really these concepts that, data scientists and machine learning practitioners kind of live and breathe on a day-to-day basis. So really a great way to get started. Now, I'm going to switch gears now. So give me 2 seconds. I'm going to switch the other presentation. So we're going to cover a couple concepts within machine learning. So next, I wanted to double click on what we saw earlier and some of the AI services. So we're gonna focus on conversation stories, Lex, Alexa, and beyond. I know I mentioned Lex is our chatbot service, natural language processing, natural language understanding, but really Lex is the engine that drives Alexa as well. So, everything that Alexa performs is driven by, our Lex service. So we're going to see an example of what that really means. So I don't want to keep doing this because some of these beginning slides are what we went over, but obviously, what do customers want to do on AWS? We want to build, we want to focus on what differentiates, we want to move fast, and we want to stay secure. So that's why we have these AI services. So you can definitely build and move fast. You don't have to reinvent the wheel. You can just, in your existing application, make a simple API call to our AI services to return a result that can enhance or enrich your existing application and data that you want to display or show or perform actions against in an application. So setting the context here, the advent of conversational interactions in computer models. First generation, machine-oriented interactions. We really, hardware was a driving force of it. Wires, in the physical world, if you think back to AT&T, you have operators connecting switchboards, to make, a call. And even before that, we have, a telegram. So again, this is the first iteration of, conversational interactions with machines. The second generation, I think we're all still very entrenched in the second generation, whether it's email, asynchronous conversation, chat, IM, even text messages, more of a real time. But again, it's control oriented and translated through an interface versus very specific hardware that performs a very specific function. So leveling up and going one step further, the third generation, intent-oriented. Intent-oriented is where we ask and the machine will interpret it based on its natural language understanding. So what is the intent of the question?
Hello again. I think you need to stop sharing your old slideshow if you're presenting a new one. Sorry to interrupt, but...
Oh, no, sorry. I'm sorry.
Yeah, no problem. Just wanted to keep things under control, you know what I mean? So.
Yeah. Sorry about that. Let me...
Yeah, sure. Thank you.
You see my screen now?
Yep.
Okay. We talked about this just for context. Now we're in the third generation, intent-oriented. How does a machine interpret an intention, the intent of the question to perform additional actions? So if you look on the left side of this box, right now, in order to script something out or something, or ask someone to retrieve information in an application, you have to log into something, you have to launch a word processor, you have to remember your file name, you have to remember, the file, open file dialog box, locate the file, and then once you locate the file, only then you can begin work. Now with intent-oriented, conversational interaction, you can simply just say, hey, agent, can you find my files in the box for the project and open them in Word? And, based on the natural language understanding, it'll know, hey, you're looking for a document. You said Word. I found the document in your file system. Since you said Word, we're going to, execute this executable, into the word processing. Now, there's an interesting quote here. I know we're in 2021, but I think this is still a salient point to make here, because Gartner quoted in 2019 that by 2022, 70% of knowledge workers will interact with conversational platforms on a daily basis. Personally speaking, I think we're ahead of the game here, because I just remembered this week I had to file a claim with my pet insurance, and that was through a chatbot. I had to reserve a table at a restaurant, that was through a chatbot. Things at work, sometimes I have to interact with a third-party vendor, and just before getting in touch with a human being, I had to go through a very iterative process with a chatbot. So I feel like even my colleagues, we're at the line at 70% or more. So I think we're ahead of the game here. Hopefully the audience can kind of feel in their experience where we are. You may have less interactions with chatbots, but I assure you by 2022, I really feel like the statement's still going to hold. Okay, business value of chatbots. We want to help the customer use the growing number and complexity of offerings. Customer service improvements. Now, again, obviously, if in your experience in your day-to-day, if you want calling customer service, you definitely want to get to as fast as possible and as quickly as possible to be in front of a human being to help answer your questions to get the help you need. But really, a lot of times with chatbots, it could be the very first step of an intake process where you're asking maybe 3 or 4 core questions of the problem, and thereby it will efficiently process the intent of the customer and then route you to the most appropriate agent versus waiting online. Because if you wait in line and put on hold, you're just in a serial queue where you get to the human and like, well, that's not my department, let me switch you over. I'm sure we've all had that experience. So with chatbots, it's a way of instantiating that intake process without a human, and allows the users to at least capture what the problem statement or their intent in order to get routed to the most appropriate. And again, their problem may get routed to a queue that has less than 5 people in it, and they have they can get help within 2 or 3 minutes, even seconds. Other times, get routed to another agent with a problem that is a known problem that they may still have to wait, but at the very least, everyone calling into the call center will get routed, so not everyone is waiting in line. I went through all of that, so I don't want to. Sorry for the eye chart, but this is a lot of this stuff going on here. But I think I just summarized exactly what these points say. But really, chatbots are to staff leverage internal data assets, functions, and business processes in the most efficient manner. So again, we can have a whole team in the call center, but really we want to use chatbots to have natural language processing and understanding baked in order to be highly efficient and route everything to the most appropriate teams. All right, let's get into Amazon Lex. And I assure you, I want to get into the demo. I don't want to do a lot of slideware, but in the end-to-end process of one-click deployment, managed service, and we have the scale of AWS. So depending on how popular or how much usage your chatbot has, AWS will automatically scale your environment to accommodate the incoming requests and interactions of your chatbot. You can instantiate business logic, analytics to improve. So at the end of the day, how well did your chatbot perform? More on the user experience side, text to speech, speech to intent, and dialogue management. How do we maintain? Do we capture all this? Do we get better in our training with call center staff, or even help staff, or even someone like me who's receiving a lot of requests on a daily basis? Chatbot could help me kind of understand what's coming without me, with an open Slack channel or, just people calling me on my cell phone. So think of a way to augment a lot of the, routine work that we all kind of undertake as part of our day job. And most importantly, security. Data is encrypted in transit and at rest. And again, the full scale of AWS on top of Amazon Lex. I don't want to bore you with the use cases. I think we double clicked on the contact center bot, but really I want to focus on application bots, build powerful interfaces to mobile applications, ordering food, ordering, flowers, booking tickets. So really part of my demo that we're going to build out here today would be application bots. And, to set the stage of what we're going to see in the demo, anatomy of a conversation. So what happens in a conversation? We have 3 main components of a chatbot in a conversation. We have utterances, intents, and slots. Utterances is how do we, wake up the agent? What is the key word to speak to invocate or initiate, the chatbot itself? So that will segue into, programming your intents. The intent is to, what is the intention of the question? What is the customer, asking me? What is driving, the needs of the customer? So that's an intent. And through the intent, slots or entities rather, either or. I kind of use those terms interchangeably, but in the Lex service, we use slots, but in a past life, I've used another chatbot service and it's known as entities, but think of it the same. It's like what it is that we're actually asking to confirm with the user. So is it a type of flower? Is it a flower? Are you ordering coffee or pizza? So that's an entity, and we capture those in slots when we build out our chatbot. And through it all, kind of interacting with these three main components is our natural language understanding engine. That is the key to our AI service and how to interpret what's coming in. What's the intent? How do I interact with entities to give, what the customer needs? High level flow right here. So we saw the anatomy of it, but what is the flow of this mentioning intent, utterances and slots? So really the intent of the customer is to book a hotel. So it requires an input. So what is the input? So the input is the utterances, spoken word type phrases that evokes your intent. And then slots, again, entities. I want to book a hotel in New York City. So that's an entity in a slot. Fulfillment is you confirm as a customer, say, yeah, absolutely, I want a hotel in New York City. So that's how we program the chatbot, and reaches its final destination, which it fulfills your request, where you can write additional logic to then book a hotel and update your records in your hotel software management suite. But again, forgive me for boring you with the upfront slides. I just wanted to set the context for what we're going to do. So again, we learn by doing, we learn by seeing. So we're going to build a chatbot in 10 minutes and then an Alexa skill in 5 minutes. And let me share my full screen and not window. Okay. Can everyone see my screen?
Yep.
All right. So Amazon Lex. So again, you get into the AWS console, but really, it's super simple, right? We want to, create a chat bot, and right now we want to do a custom bot. So if we do a custom bot, and in respects to time, I already pre-baked some stuff, but just to show you how easy it is, we would just select, English, choose a voice. Let's do Johanna. Here we go. 5-minute timeouts. No, this won't have subject to Children's Online Privacy Act. Okay. And that's all it is. So once you create a custom chatbot, you have this blank canvas to get started. So just running through in the left side of it, you'll see intent slot types. I took the liberty of creating a coffee robot. Now with our coffee robot, we have a couple intents here. So customer order. This is where the customer want to make an order, but really we want to greet the customer. So, this is where we would sample utterance. How do we wake up the agent? So I'm thinking my utterance is, are you open? Is anyone there? Then once that is received, the natural language understanding engine will say, hey, in this chatbot, I'm programmed to recognize this. And once I recognize this, I know to then, fulfill that request in a slot. So let's see what this looks like. So here, in our slot, in our entity, we have menu options. So really, I'm just saying, hi, Coffee Bot Express. We have 5 different options, regular coffee, latte, mocha, cappuccino, espresso. Again, we'll be adding new options soon. Stay tuned. Would this interest you? So that's kind of like greeting the customers. But what's the next intent? Obviously, like, hey, all right, Coffee Bot, like, what would the customer want to do next? So it's like, I'd like to order something and make an order. Let's say, sometimes. Okay, so I'm saying I'd like to order coffee. So once the utterance was set by the customer, the natural language understanding engine will receive that, know that it was programmed to interpret that in order to then fulfill that request through its slot. So if you look at my slot types, we have type of coffee, temperature of coffee, and type of cream. So let's say hot. What type of creamer? I'm a purist, so I just like half and half. So let's do cream. I didn't like what I mentioned here, but okay. So here we have in this chatbot right now, there's a number of different things you can do. For right now, because we can integrate this application, this will output like a JSON document that you can feed into, like, let's say, a point of sales machine to then create a receipt or a order number for the baristas, so to speak. So hopefully that makes sense, but it'll make even more sense when we take this chatbot and we create an Alexa skill. So in order to create an Alexa skill, rather, you know what? Let's see this end to end. Iced? Sure. Let's go small. Take cream. How many? Oh gosh, I'm making an order for the entire office and my colleagues, so 5. Name for the order. Again, each step here, I am stepping through the slots. The slots are entities, so each entity could be coffee type, temp, size, creamer type, numerical value of coffee count, and the customer name. So again, as you see fulfillment, I'll say, thank you for your order. I have 5 iced coffee with cream for Randy. Is this correct? If I say yes, it'll respond to you. So hopefully you can see like this interaction. So you can think of it as a way where, you're a small coffee shop, you want your baristas focusing on their craft of creating the coffees and less about, the intake process. So you could very well think of, having, iPads in the front to greet the customer. I know that's taking the personal out of it, but just for the sake of, let's say you're a busy airport, I think customers would appreciate that if you're at a busy airport. But okay, so now that you've seen this chatbot, its operations and the way it behaves, how do we then take this and turn this into an Alexa skill? Super simple. So if you select the coffee chat, you want to export this. Let's take the latest version, so version 8 of mine. And what do we want? So we already know this is an Amazon Lex bot, but we want to take everything we built in Lex and kind of generate JSON files to, be compatible with an Alexa Skills Kit. All right, if I save that. Now again, I'm going to pop into the Alexa Development Council. And again, for the folks in the audience, it's free to sign up. Once you have an account into the Alexa Developer Council, you have the capabilities of building out your Alexa skill. Let's get to it. Skill name, let's say I already pre-baked something, but for the sake of demo, let's gonna do it real time. A coffee robot. I want to create a custom skill. That's already defaulted. But here, we want to provision our own because we already created something in Lex and we already have the JSON output. So provision our own. Create the skill. We're going to wait a couple minutes. I want to start from scratch. Like, again, if you're interested in learning more about Alexa skills development, we have a number of blueprints to get you started, but we're starting from scratch only because we already know what we want in our Alexa skill. So I'm choosing from scratch. Takes only a couple seconds, I swear. Okay, so, once you're in the Skills Council, you have a whole host of menu options, build, code, test. Now, really, you can code within the Developer Council here, but because we're selecting, it's not Alexa hosted because we wanted to provision our own. So we're not going to go here. We're just going to stick to the build area. So in the build area, we want to start with invocation name. How do we tell Alexa to get started on this skill? So, we want to tell Alexa to start the coffee robot. Okay. Coffee robot. And our interaction model. see here, this is all the default stuff. We don't want that because we already built the LexBot. So here you'll see this, drag and drop a JSON file. I'll show you. Here. Like this guy. Sure. Sorry. And it's really simply dragging and dropping what we just exported in the Lex console. We're going to save our model now. The one thing we overwritten was some of the required defaults. So here we want to add additional tens, but really we're going to stop that. Cancel. These are default options for the Alexa skills to get out of its kind of location. So these are just default things. It has nothing to do with the skill that we're doing. So cool. All right, so here you'll see all the stuff that we created in our LexBot. Here you'll see those slots and entities, and they're all in here. So if I save the model, I like to see those changes, but if we go to test now, allow. So here, definitely are in development mode. Once we're in development mode, we can get started. So I mentioned we had to set a name to invoke the skill. So if you recall, we named it the invocation as the coffee robot. So I'm just gonna go, hey Alexa, please start the coffee robot. Sorry about that. Alexa, start the coffee robot.
Okay, here's our robot name. Which robot would you like to use for this job?
Well, good thing I built this earlier for you guys, but there may have been some kinks when I just imported it, but I assure you we're going to get started here. Alexa, start CoffeeBot Express. And as you can see, when you launch a request, you're going to see, the inputs and the outputs. Now, this is important if you're a developer. You want to know where you are and, kind of things you're interested in terms of parameters to enhance or enrich different aspects of your application. And you can say, anyone there?
Alexa,
anyone there?
Stop.
Is anyone there?
Yes, we are here.
I'd like to order an espresso. Doesn't like my microphone. Sorry. Can I order a coffee? Can I order a coffee? Two. Cream. Randy. Sure. One second. Alexa, start Coffee Bot Express. Anyone there? I'd like to order a coffee. Two. Respects the time. Randy. Large. Iced. Yes, it is. So if you look here on this, you can program Alexa not to speak with, some of the outputs, but really if you think about it, this output here can be instantiated in your code to then integrate with a ordering management system to say, hey, it's integrated, it's gonna, coffee temp, sorry, it should have been hot. But as you can see, you can organize, the order type, all the rest into kind of very structured format to then, have a confirmed status. So then the baristas will get an alert and they'll get started on fulfilling that order. And if you look to the right pane here, you'll see, everything that we were interacting with Alexa. You'll see how, the code was interacting. And thus, if you were to see errors like down here, this could have been the natural language understanding, or even, my earbuds right now, they didn't understand that I said iced, things like that. But this will help you kind of iterate through your code to make sure that you're building an Alexa skill or a chatbot that provides the best experience as possible. So I'm glad I'm running 5 minutes on time. I was afraid I wasn't going to make it, but before I end, we have 5 minutes. Are there any questions?
Right, so basically you started off creating a chatbot, and then using the AWS services, there's like automatic text-to-speech that it could incorporate and interpret, and then basically deployed it on Lex?
Yeah, that's a great question. So what we really saw here was that we're really focusing on customer experience, customer outcome. We're really thinking, how does, a customer initiate the chatbot? How does it, share what it wants to, as a customer, what do I want to order? And if you saw the demo, you didn't have to program natural language understanding code. You didn't have to understand how the NLP would process, the intake, and taking it one step further, the responsibility is not on, you as a developer, because you're probably integrating this chatbot to your, wider application, whether it's a storefront, a restaurant front, or the like. So you're not responsible for the hard work of being a machine learning practitioner. So hopefully you see the power in some of our AI services where, you really get to focus on what you're building. So you're building customer experience, and part of customer experience would be, this little function right here to, receive customer orders. Does that make sense?
No, thank you.
I have a question. So how easy is it to deploy these chatbots on, like, say, someone else's Python code? So, like, say, for example, if someone else wanted to do their projects, would they just have to do the same steps you did to just deploy it on, like, their own code or whatever they felt like it?
Yeah. So you can get started with that export, but really, that's a great question. So in addition with just clicking around in the console, we have the concept of, again, being fully integrated with all the AWS services. We can instantiate and initialize Lambda code written in Python. So again, if you have a very robust and comprehensive, entities that you want to interpret, by all means, use your IDE of choice, use your repository of choice, make sure everything is working, and it'll trigger a Lambda function. So you don't have to, click around and build a chatbot. It's not necessarily the all and be all of the user interface. And really, at AWS, we put all the tools to the builders, and builders want to write code. So absolutely, you can write code. And with our Amazon Lex developer guide, it'll guide you to let you know what types of parameters to use, API structure to build out your Python code in Lambda. And then when you start to build this out, you can click this button here to do code validation, things like that. You can have another hook. There's a lot of different areas. So that was one area. You can also take your Lambda and also kind of go to where the slot types are. So there's many different possibilities to build your chatbot. So it's just not relegated to the console itself. So you can definitely write Python code and then integrate it to the service.
Yeah, thank you. I'm sure it'll be very cool to see, like, some projects maybe that involve this in the future, or maybe even in this hackathon. So.
Okay, great. We're right at time here. I just want to express, again, my appreciation for inviting me. I had a super fun time preparing. I hope folks learned something, and I hope it was a good use of your time. And as always, good luck to everyone that's participating in the hackathon. I think you guys are doing a great job. And from all the projects I saw last year, I have no doubt this year you guys are going to level up and take it to the house. So again, I definitely appreciate your time and inviting me yet again. Have a great day and enjoy the weekend, and have a great hackathon.
Right. Thank you so